Good afternoon and welcome to Blueprint for Efficiency, a webinar speaker series hosted by the Yale Center for Business and the Environment. My name is Lynn Tran, and I will be your host for this afternoon's presentation titled Harnessing Energy Embedded in Water. The Yale Center for Business and the Environment is pleased to present Blueprint for Efficiency. This series of public webinars emphasizes the latest opportunities for energy efficiency. Through presentations that look at corporate, nonprofit, and public-private developments, Blueprint explores energy efficiency through the lenses of behavior, policy, finance, and technology. Each presentation is recorded and available on the Blueprint for Efficiency website and the Yale University iTunes channel. Please join us next Tuesday, March 31st, for Secondary Markets in Action, Case Studies of Mobilizing Capital for Energy Efficiency. We will discuss 3 secondary market deals that have been executed in different states and market segments. In today's webinar, we will continue to explore synergies in water and energy management practices with our speakers Amelia Nuding and Gretchen Hardison. Amelia Nuding is a water energy analyst for Western Resource Advocates. She works with utilities, municipalities, and state agencies to align water and energy efficiency programs and improve the integration of water and land use planning. She has worked in the environmental sector for over a decade and has also been a science teacher for several years. She has a master's in water resources management from the Bren School at UC Santa Barbara and a bachelor's in physics from Vassar College. Gretchen Hardison is an environmental affairs officer with the Los Angeles Department of Water and Power, the Municipal and Electric Utility for the City of Los Angeles. As a member of the Efficiency Solutions Division, Gretchen oversees community partnership activities, including the partnership with Southern California Gas Company for joint customer incentive programs within their shared territory. Prior to her 5 years with LADWP, Gretchen managed the Air Quality and Climate Change Group at the city's Environmental Affairs Department and worked as an environmental consultant prior to that. Gretchen has a master's degree in urban planning from UCLA and a bachelor's in social ecology from UC Irvine. Finally, we would like to remind our listeners that we welcome any questions you might have and will direct as many as we can to our speakers. For today's webinar, we'll pause for questions in the middle of the presentation and as well as at the end of the presentation. Please type questions directly into the GoToWebinar chat window throughout the presentation. And with that, we welcome Amelia to Blueprint for Efficiency.
Thank you so much, Lynn. Hi, everyone. Good morning and good afternoon, depending on where you're at. My name is Amelia Nuding, and today I'm going to be talking about harnessing the energy embedded in water. When we talk about what the energy embedded in water is, typically we mean it's the energy inputs that we use to pump, treat, and heat water for drinking and for wastewater treatment. It's been estimated that 13% of total energy use in the U.S. is related to water services. So it's a pretty significant portion of our energy use. When you look at how this impacts municipalities, it typically is a pretty significant portion of their total energy costs if they own and operate the water treatment plant and or wastewater treatment plant. So what I'm interested in is not just the energy inputs that we have in water, but how can we get more energy outputs from our water systems. This is a diagram of the basic water supply system. It comes from some source, whether it's a reservoir or from underground or traveling across the land up and over a mountain. It gets pumped to the water treatment facility and treated, distributed to customers. That's the red end-use box. And then eventually goes on to wastewater. There may or may not be some recycling going on. It's discharged and then becomes the source for the next community downstream, assuming there is one. We're going to look at this in sort of 3 stages, looking at the energy efficiency opportunities and energy generation opportunities. But to start off, we're going to start in the middle, actually, that red box that says end use. And there's a good reason why. Heating water, that's the primary energy input at that stage, is the most energy intensive stage of the water use cycle. People often think of desalination as the most energy intensive process related to water because we all know several desalination projects are not viable economically because the energy costs are so high. But on a energy input per water unit, per acre foot or gallon basis, heating water is at least 10 times as energy intensive as desalination is. So it's a really important place to look at energy savings and water savings. And if you're interested in how you can make some efficiency improvements in your own home, you might like to know that heating water typically accounts for about 20% of your home energy use. So combining these energy and water efficiency programs is something that I called conservation synergy. This is a smart thing to do. We've got energy utilities and both electric and gas and water utilities implementing efficiency programs, but almost all the time these programs are managed entirely separately, even though there's a lot of savings to be realized between the two. These programs can not only be implemented by utility through a collaboration, but they can also be done by third-party programs. This image on the right here is an image of a report that I did when I learned about a few utilities who were working together to integrate their energy and water efficiency programs. So I'm going to walk you through a few of those examples. The first type of the utility collaboration that I looked at was a joint rebate. So this is a rebate that's offered by both Pacific Gas and Electric and 41 water agencies. That is because the energy utilities distribution area, service area, is really large, and typically water agencies have a much smaller distribution area within. So in order to cover the entire service area for PG&E, they had to work with this many water agencies. They got together, and at this point they have a $150 rebate for the highest efficiency washing machine programs. This program has been in place for a few years. At the bottom of the screen there's a link to their website. And within the first couple years of this program, PG&E saw a 63% increase in participation as compared with when they ran this program by themselves. It's consistently been ranked highest in customer satisfaction because their customers are getting the benefit of a one-stop shop. They don't have to work with several agencies. And they have seen lower administrative costs because of the efficiencies of working together. Another type of utility collaboration is a joint audit. Audits are an extremely effective way to achieve energy and water savings, but they're pretty expensive. It requires a lot of time from an expert who goes in there and does, very hands-on work and looking at what are the opportunities for more energy and water savings. Well, in Austin, Texas, the Municipal Water Utility, Energy Utility, and Texas Gas Service got together to develop a tri-resource program. Originally, this was offered to single-family residential homes, and after the success of that, they decided that it would make a lot of sense to try to bring this to the multifamily housing sector. This is a typically difficult sector to reach because of the split incentive. There's a person or an entity who owns and operates the building, and then there's the renters. So if you make efficiency upgrades, that cost is usually borne by the owner, but the benefits are seen by the bill payers, the renters. But because these three utilities got together and offered a high-value package, they were able to overcome that split incentive and had an incredibly high rate of success and willingness of multifamily housing participation. In about a year's time, they reached almost 2,000 multifamily units. And the way they organized it is they had an auditor from Austin Energy go into the various units and survey everything that was going on. He or she would install low-flow faucet heads, aerators, and low-flow shower heads immediately, and also efficient light bulbs, and then take note of the other aspects of the building and the units that might benefit from an efficiency upgrade. That report would then get sent to each of the utilities. They would review and then contact the building owner. This has been a really popular program. They continue to work together and may potentially expand this to the commercial and industrial sector as well. A third type of collaboration is joint marketing. This is actually an example of a collaboration that I helped to forge. It was between Xcel Energy, which is the largest electric and gas provider in Colorado, and 6 water utilities. 2 of them are the largest water utilities in Colorado. When I went and spoke with them, I sort of casually mentioned the idea of, working with Excel or working with the water utilities, and I was really pleasantly surprised at how eager all the utilities were to participate. Some of them said, we've been thinking about doing this, but just never really happened, didn't have the time, didn't know who to talk to, so they really just needed someone to bring them together. So we got together, we sat around a table, and we reviewed all the existing programs that were going on and looked at some of the near-term future ones. And the utilities decided that what made the most sense was to embark on a joint marketing campaign for an existing efficiency program that's targeted at commercial businesses with refrigerators. This is a very niche area, and it's sort of a difficult to reach sector because if you're looking at your database of customers, it's hard to know which ones have these commercial refrigerators. So Excel really benefited from the help of just getting the word out, and the water utilities benefited because when the staff person went into these commercial businesses, they would automatically install pre-rinse spray nozzles and faucet aerators. So together we developed a few pieces of collateral, and about 800 flyers were sent out last year by the water utilities, and we expect that number to be sent out again this year. The last type of collaboration is probably the biggest and most significant collaboration in terms of the sheer number of programs offered, and it's really interesting. So I'm very pleased to have Gretchen from LADWP talk about her program. Gretchen, on to you.
Apologize for the technical difficulties. Gretchen will be on in just a minute. Gretchen, are you on?
My apologies, yes.
Oh, no.
Forgive me.
Yep.
I'll do a quick introduction, and thank you, Amelia. I had forgotten to take myself off mute. It's a pleasure to be here, and again, my name is Gretchen Hardison, and I work in the Efficiency Solutions Division at DWP, which houses both electric energy efficiency and water conservation programs. I'm going to give you a little first-hand perspective on the topic of developing collaborations between utilities. So here, as you can see, a little background on the utilities in the City of Los Angeles. As indicated in our name, LADWP is a department of the City of Los Angeles. We're owned and operated according to city charter and city ordinances. We're the largest municipal electric utility in the United States, serving about 4 million residents. We have in the neighborhood of 1.4 million electric meters and 680,000 water meters. Southern California Gas Company, whom we affectionately refer to as SoCalGas, is the local investor-owned natural gas utility that covers much of Southern California. About 20% of their gas meters are located in the City of Los Angeles. So energy efficiency programs of IOUs in California operate under the oversight of the California Public Utilities Commission, and publicly owned utilities receive oversight from the California Energy Commission. So our regulatory structures are distinct. DWP, in addition, operates under the authority of a 5-member Board of Commissioners with oversight provided by the Los Angeles City Council. And while there are a number of joint individual programs between IOUs, often at the direction of the Public Utilities Commission, IOUs and POUs don't typically work together until now. Just a few items here in the regulatory framework here in California that helped set the stage for our partnership. In 2005, we had state legislation, Senate Bill 1037, that required POUs to make energy efficiency a priority, even though many of us had been investing in energy efficiency programs well before that date. A few years later, the investor-owned utilities were directed by the PUC to support local government efforts to improve energy efficiency. They having the larger utilities having more experience than most of the municipalities in this area. There's also a lot of public interest in energy efficiency, and many organizations and initiatives were looking at energy efficiency as one way one very good way of reducing greenhouse gas emissions. So DWP and SoCalGas had tried to partner in prior years on a few different programs, but they were always kind of one at a time, and we couldn't quite get through the challenges that were posed by partnering. In one example, DWP had federal grant funds to put toward a joint energy efficiency program, but SoCalGas was prevented from accepting the federal funds because of the reporting requirements and the other strings attached to that funding source. But a turning point kind of came around in 2012. Our board, the mayor and city council, increased funding to the efficiency group here at DWP and formally adopted a goal of a 10% reduction in electricity use by 2020, which was actually the goal, the target that the Energy Commission was expecting most municipal utilities to comply with. But at that point, energy efficiency was written into our integrated resource plan on the supply side to help replace power from other generation sources. And by the way, that target of 10% was increased last summer to 15% reduction by 2020. We had a new general manager, and other conditions here were really ripe for a new approach to energy efficiency. And SoCalGas was thrilled that we were finally ready and able to partner in a large way with our neighboring, with our sister utility. So as we sat and discussed options for partnering, we identified some common goals and the values that we could achieve in partnering, namely achieving our respective energy efficiency goals, which, as you all know, becomes a little more difficult as we go through that low-hanging fruit, and to better serve our joint territory customers. So we developed, in a relatively short period of time, about 6 months, our teams put together a master inter-utility agreement for energy and water efficiency and resource savings. So behind the scenes, there were multiple drafts, lots of phone calls, meetings with our attorneys, redrafts, running up and down stairs trying to get people to listen. But because we had willing partners in the two utilities and we had strong support from our executive management on both sides, we were able to put together an agreement that both utilities could live with. Again, the goal was to share costs while delivering tri-resource programs within our joint service area and to allow a high degree of flexibility to create new programs and modify existing programs as needed. Contracting is really very difficult for DWP, and we really wanted to make sure this one was going to serve our needs. So I'm going to talk more about the process on the next slide, but here's a little snapshot of our current status. We celebrated our 2-year anniversary of our partnership in last September, and we also renewed the master inter-utility agreement for 3 more years through the end of 2017, and we expect to extend that again through at least 2020 and hopefully well beyond that. We have launched 11 joint programs to date, and we have 3 or 4 more on deck to come online in the next couple of months. Early on, we held a joint training for the account managers from each of our organizations so they could become more familiar with the joint programs we were doing, but also become more familiar with the solo programs of the partner utility. One of the things we've had to do is to teach ourselves and really learn to get in the habit of referring our customers to our partner utility when our utility doesn't have a program to support a particular customer need. And I'm going to jump to the next slide to discuss these last couple bullets. So here's a simple diagram of how the master inter-utility agreement works. The MIUA provides the structure of the agreement. In this document, which was approved by our board, we have the purpose of the partnership, the general terms and conditions, the length of the agreement, any termination clauses, and how we're dealing with confidentiality of customer information and data. This really is our high-level document, sort of our contract, although we don't call it a contract, from which we tier program orders. The program orders are similar to a task order under a contract, and again, they tier from the master agreement. And this level of document can be approved by management at both utilities, and that was written into the master agreement. The program order describes one joint program. It identifies the lead utility, the program managers, the roles and responsibilities of each utility. It describes how the program runs, how we'll coordinate together, the program budget, the cost share between the two utilities, and how the lead utility will invoice the partner utility. This structure provides us with a lot of flexibility. Once our teams agree on the concept of a joint program, we can usually put it together in about 8 weeks. There are some programs that have taken several months because we have to navigate either our different regulatory structures or our financial structures or some element of how we roll out our work programs. But for the most part, they're pretty easy to get going. The joint programs are generally an expanded version of an ongoing program. The lead utility will have a program that would benefit from partnering with our other utility. Sometimes, for example, natural gas programs benefit from including electric measures to attract more customer interest and that have the promise of higher incentives for customers. For DWP, partnering with SoCalGas has allowed us to offer our customers in the City of Los Angeles a number of statewide programs that were not previously available here. So this brings more consistency for the local contractor community who works across jurisdictions within the region. Here we've displayed our current 11 joint programs. Many of these, again, are statewide programs that are offered in the investor-owned utility territories under the direction of the California Public Utilities Commission. They include joint incentives for new construction, both residential and commercial, a number of direct install programs where work crews will go out and install measures that are free to the customer. And we also jointly support the work of the Los Angeles Better Buildings Challenge team. And we DWP has been able to participate in statewide organizations and groups dedicated to advancing codes and standards here in California and looking at emerging technologies statewide. We're working to launch a few more programs soon, as I mentioned earlier. The Energy Savings Assistance Program, which is a direct install program for low-income residents. We hope to get off the ground and work with our city housing authority in the next couple of months. We're also looking at a program to fund energy and water efficiency training for building operators, as well as new curriculum in our local school district. And we're looking at the food service industry as a particular point where we can provide joint incentives to take advantage of natural gas, electric, and water savings there. Again, some of the points that we try to keep in mind as we're looking at new potential programs is how can we better serve our customers through a single point of contract? Where can we achieve water savings with ongoing gas programs? Where can we achieve electric and gas program savings together? Again, DWP is very fond of the joint programs because they really allow us to expand our reach, impacting more customers, generating more savings toward meeting our goals with minimal impact on our staff. Gas Company has been very gracious in bringing us in to some of their ongoing programs and expanding those to the City of Los Angeles or extending them through including electric measures, which again can sometimes attract more customers to the programs. And the partnership has really raised both the profile of DWP at the state level, as we're now beginning to participate in discussions with the investor-owned utilities. And SoCalGas, I would note, also has derived a number of benefits from working seriously and at length with the municipal utility. A few highlights from the partnership that make this successful. Really very important top-down support from executives at both utilities has really made this happen. Staff level, we keep it going, but the commitment from the top really got us started. It's important to be open to new opportunities, and we are learning to be aware of the restrictions of rolling out programs with our partner utility. In terms of marketing, we have agreed to always feature both logos on promotional materials for the joint programs. We've gone on to hold joint events for our staff. We've had a couple of joint Earth Day celebrations and some other events. As for benefits for our customers, we see increasing incentives and really, again, the expansion of statewide programs into the City of Los Angeles territory that were not previously available. I'll also note that the partnership with DWP has really served as a model for Southern California Gas to partner with other municipalities in their territory, kind of work through the kinks with them, and they have rolled out and now have partnerships with the public electric utilities in the city of Riverside, Anaheim. They're coming online with Pasadena, and they have a new partnership with the Metropolitan Water District. Obviously not on electric programs, but on water programs. So to wrap up, I'm just showing a little snapshot here of some of the measures of success on this current round of programs. The new construction programs, again, are statewide programs that have been available outside LA and are now available with looking at the three resources, natural gas, water, and electricity for residential and commercial. We have a multifamily direct install similar to one of the programs Amelia mentioned earlier, where third-party contractors will go in and just switch out faucet aerators and shower heads, and we've been able to save millions of gallons of water and hundreds of thousands of therms. Energy Upgrade California reaches our single-family residents at this point. We hope to expand that to include multifamily residents later this year. And again, we're partnering on with the Better Buildings Challenge, Code Standards, and Emerging Technologies. So thank you for your time, and I'd be happy to answer any questions.
Great. So we have a question from David for Gretchen. Does LADWP provide financing options for their customers to implement the recommended measures?
We have only one true financing program in-house, which is an infrastructure loan program. We are looking, in fact, I met with SoCalGas just a couple of days ago to look at financing pilot programs that are going to come online here in California later this year, hopefully. We have not been able to host an on-bill repayment or on-bill financing at this point in time due to some constraints we have with our customer billing system. But we are actively looking with SoCalGas to see how we might be able to partner in financing. And we do have an active PACE, Property Assessed Clean Energy Financing Program here in the County of Los Angeles, which all of our customers have access to.
Great, thanks, Gretchen. And we have a second question from Jonathan for Amelia. Can you please explain how higher value packages overcome the split incentive?
That's a good question. I think it's because, so when you think about what a building owner pays for, sometimes they pay directly for the water if those units are not sub-metered. But the energy benefits, the energy efficiency installments, those benefits would accrue to the renters. So by combining all three, the renters receive a benefit and the owners receive a benefit. It's also possible that with the gas inventory, that the hot water heating portion of it and the efficiency installments there, those benefits would accrue to the owner. So all that combined, the owner does see benefits, and then there's also sort of the long-term possibility that the owner can advertise those rental units as more efficient, which would likely be appealing to renters.
Great, thanks so much, Amelia. I'm going to turn it over to you to finish the rest of our presentation, and we'll continue to do Q&A once you conclude to wrap up the webinar.
Okay, great. So just to wrap up this portion of the webinar about inter-utility collaborations, I wanted to highlight to you some of the benefits that were identified by collaborators. So this list is not meant to indicate that all of these benefits will be realized in any given partnership, but rather this is sort of the laundry list of folks' experiences. So several utilities found that they had higher participation rates, and that was in part attributable to broader promotional strategies. PG&E worked a lot with the water utilities to get the word out in retail stores where these washing machines are sold, to really get the word out to customers. With all of that quote-unquote manpower, they were able to get the word out more effectively. Some utilities saw lower costs through shared administrative processes. And in general, almost all the utilities reported increased customer satisfaction. They have a one-stop shop experience rather than having to work with 3 different utilities or 2. And customers see their utilities as working smarter and not harder. They also benefit from coordinated and complementary program design. I have actually seen an energy utility and a water utility who are both offering shower heads. These were slightly different models, and they were effectively competing with each other because they had slightly different processes for how they were distributed. So really, we don't want any competition in these programs. That's one of the good reasons to work together. And then it paves the way for long-term collaborative opportunities, which I think has been shown very well with LADWP-SoCalGas. But of course, it's not always easy, right? There is a significant upfront time investment. There's no way around that. Once the partnership is well underway, you've sort of created the pathways that will enable easier partnerships down the line. But at first, it's going to take a while. You've got to get folks from your finance and marketing and efficiency program operations all on the same page. You're essentially establishing new processes. In the report, I talk about, I provide sort of a guideline for the collaborative process that just sort of highlights some of these things to watch out for and ways to overcome these barriers. There are also differences in service territory, as I showed you with PG&E. Typically, an energy utility would have to work with a lot of water utilities, and that can be challenging and daunting and perhaps a barrier. There are certainly differences between the way in which water utilities operate their efficiency programs and energy utilities operate, particularly if that energy utility is regulated by a public utility commission. They are used to a pretty extensive process and rigorous analysis, whereas those that don't have to have that level of regulatory oversight tend to have really different ways of running their efficiency programs. So that can lead to differences in data collection protocol and expectations. So it's really important to sort of hammer out those expectations early on. One of the ways that you can do that is by establishing a memorandum of understanding or inter-utility agreement. That can help to establish the trust that's needed. Trust was a big issue that came up for a lot of utilities I spoke with. They just didn't know who exactly they were working with until some time had passed and their partnership had evolved. And last, unfortunately, regulatory bodies can be a barrier, although in California they really help to pave the way for several utilities to collaborate. But I can tell you from my experience with Xcel Energy and the water utilities in Colorado, there were some challenges with sharing data, and that ultimately came down to a regulatory issue. So it's important to be clear on how each participating utility is regulated and what standards they need to adhere to. So we're back to this diagram, because as you recall, we were talking about sort of that centerpiece where I put water use. So now we're going to sort of take a step back and look at the whole water supply cycle and look at where there are opportunity efficiency and energy generation. And I want to take this step back and take a broader look at how we think about water management, because I think it's high time that we view water management a little differently, not just as water management, but water, energy, and even municipal waste management. That's why this slide is entitled A New Paradigm, perhaps a bit lofty, but we need this different sort of thinking to chart a different future as we move forward. So one small difference in this chart compared to the first one that I showed is the red box. The first time around that was called end use. That is the most common term used to describe the customers who are receiving the water. But I want to change that term. I don't want to call it end use. One, there's the obvious fact that it's clearly not at the end, right? It's in the middle of a cycle that actually repeats. But I'm not just trying to be, cutesy here. There's a good reason for removing that word, which is because end use is the wrong way to think about it. If that is the end goal of the water supply system, then you're really sort of focusing everything on those customers. But there's so much energy embedded in the other stages of the water supply cycle that let's just call those water users and look at all of the opportunities that exist throughout this process for energy generation. So first, we'll look at water conveyance and distribution. There are a lot of opportunities to install small hydro turbines in pipes and ditches as the water is flowing. We can harness the kinetic energy of this water as it's moving and getting pumped whenever there's the right level of head for it. In addition, sometimes utilities need to reduce the pressure of the water that they are delivering to their customers because it has to be within a certain range to provide regular water service in a home or business. So oftentimes a pressure-reducing valve is used, but these can actually sometimes be replaced by hydropower turbines, where you're going to be generating energy at the same time. Now, any decision to do this is, of course, going to depend on the engineering and the specifications of the particular place. And I'll also say this is not new technology. This has been done for quite some time. But the American Society of Civil Engineers estimates that more than $1 trillion in system repairs is needed in the drinking water system, and $300 billion in wastewater treatment systems. So if we're thinking a little bit bigger about our water system as more than just a water, but also an energy system, the question is, can we make some of those necessary investments pay off? How can we do it differently this next time? There's some really interesting advancements in technology that were brought to my attention by Dr. Kala Veeragamurthy. He is the Dean of the Patel College of Global Studies at the University of South Florida, and has done a lot of thinking about the next generation of water supply systems. So there are what are called smart pipes that have fiber optic sensors embedded in them that can send a signal when there's a change in strain or temperature in the pipe and alert the operation folks that likely there's maybe been some leak or some disturbance in the system. Right now, with our typical steel pipes underground, we have no idea that there's a leak until a problem occurs, unless there's some catastrophic water main break above ground. There's also a fairly new technology called self-healing pipes. And this technology was modeled after the way that our own bodies heal when we have a cut. Just in the way that platelets will help to form a scab and heal a wound, there are polymers that are sent down a pipe and ultimately fill in the breach or the break in the pipe, fill it and seal it. This is being used not only in water pipes but also in oil and gas pipes, or at least oil pipes. And lastly, there are advances in reducing the friction in a pipe. Friction is a major retarding force in terms of transporting water along, and so the more we can reduce the friction, the less energy we'd have to use to be able to pump it, to move it along. We spent a fair amount of time already talking about the way that energy and water utilities can work together to integrate their efficiency programs at the water use stage of the water cycle. But there's one more technology I wanted to let you know about. If you think about it, we heat our water, and I already told you how energy intensive that is, and we use it momentarily while we're washing our hands or showering or doing our clothes, and then it flows out of the house onto the wastewater treatment plant or septic system. But much of that heat at that point just sort of gets wasted along the way. There's a way to capture that heat through a heat exchanger. As the warm water is leaving your house, that heat exchanger can take the heat from that warm water and transfer it to cold water that's going into a water heater. It can heat water from 20 to 30 degrees using this technology. And while the costs vary, there are at least a few companies who are offering these and installing these in homes. It can be either done on an existing home or, of course, more easily in a new home when you get to design all of the engineering yourself from the outset. But the payback can have a period of roughly 5 years or more. And lastly is the wastewater portion. And this is another term that I would like to change. There is so much energy embedded in wastewater, kinetic, thermal, and chemical energy, that I think it's a crime almost to call it wastewater. We need to start calling it resource water or some other term that indicates how much value it has. Now, I'm not going to walk you through the whole wastewater treatment process, but I do want to draw your attention in this diagram to the top right portion. You see those two red bolts. It says power generation, and it's connected to a digester. This digester takes organic solids that are taken from the wastewater, and microbes digest them anaerobically without the presence of oxygen. As a result, methane and carbon dioxide are produced, and that biogas can be used to spin a turbine and generate electricity. It can also be used directly for operations in the plant that require gas. The Water Environment Research Foundation has done a lot of work and research looking at how much energy is embedded in wastewater. And they found that in the largest wastewater treatment plants, it contains 10 times as much energy as needed for treatment of that water. If we can effectively harness it, we could not only turn these wastewater treatment plants into water treaters, but energy generators as a small power plant. So again, this is a big idea. It requires, there's a lot of details and engineering and of course money that's required to get this done. But if we look ahead and we know that all of our systems require significant investment, how can we make those investments smarter than we have in the past, now that we have so much more knowledge about how to generate that energy? Well, there are a few leading wastewater utilities that are already starting to think about this. So I'm going to give you a couple of case study examples. First is a wastewater treatment plant in New York. It's Albany, New York. It's relatively small, not a huge plant, but in the 90s they found themselves oversized for the amount of wastewater that they were treating. So their first step was to become extremely energy efficient. They needed to reduce their operating costs. They did have a biodigester on site. So they actually helped court a yogurt company to locate their facilities nearby so that they could take their yogurt waste and digest those in the digesters. Food and dairy types of waste are tremendously potent producers of biogas. This yogurt company is actually Sage, S-A-G-E, the Greek yogurt company, and they have very delicious yogurt if you've ever had some. So through all of this, the efficiency upgrades and capturing that yogurt waste, they saw a huge change in their energy profile over time. This is a diagram of their energy usage from 94 to 2011. The green bar represents the electricity they are producing on site, and the yellow bar is the electricity that they were purchasing from the utility. Obviously, you see a dramatic rise in 2011. That was the result of additional biodigester efficiencies and installments that they made. But you can see that green was sort of increasing over time as they were processing that yogurt waste. In addition, with the exception of 2011, their overall energy use profile, the total, trended downward as a result of the energy efficiencies they implemented. This wastewater treatment is approaching net zero. They currently can't net meter and sell and buy electricity to the grid, but they are about 90–95% the way there. Another interesting case study is East Bay Mud in California. They're a huge wastewater treatment plant, and they've been invested in on-site energy generation for decades. They are currently actually a net energy producer. They are producing more energy on site annually than they use in a year. They do still buy electricity from the grid because at any given moment they may not be producing as much energy as they need, but over the course of the year they are allowed to net meter, and so they are a net energy generator. One of the things that really brought them to this next level was an innovative program that they developed of collecting food scraps from commercial industries and industrial food operations. Food scraps, as I mentioned, are extremely potent and produce 3 times as much methane as municipal wastewater solids when they're digested in a biodigester. So by using this, they're not only becoming an energy producer, but they are addressing municipal waste management. Food waste is a huge contributor to our landfills and is a huge contributor to methane when it just decomposes in the landfills. So this is a major asset to the local municipal waste managers as well. So by thinking this much larger, these water operators can be much more than just thinking about water and water quality, but they're thinking about energy generation and municipal waste management. There's opportunity to increase the amount of energy we generate at wastewater treatment plants. This is an image that shows how many biodigesters are located on wastewater treatment plants. Only about 10% of wastewater treatment plants have biodigesters. That number that number is the 1238 that you see. But of those biodigesters that exist at wastewater treatment plants, only about 25% of them are generating electricity. The vast majority are flaring that gas and not using it to benefit. So there really is tremendous opportunity, you know, when we're just sort of thinking big about how to do more with what we already have. And of course, as our population grows and we need to expand our facilities or possibly even build new wastewater treatment plants, these are ideas that we should be keeping in mind. So I think the whole point here is that when we start to think a little bit bigger about our future and where our water industry is headed, we need to look to these early adopters like the utilities who are working together on their efficiency programs, like the wastewater utilities who are not only energy generators but municipal solid waste managers. This is the new paradigm for water management, this integration, making use of all of these resources together. That concludes my presentation. That is my contact information, and there's a link to the report if you're interested in checking it out. And we will open it up for questions for Gretchen and myself.
Great. The first question we have is from Patrick. How are the electric savings being calculated for Austin and LADWP? Are the savings tied to water delivery and treatment?
I'll let Gretchen go first.
Well, depending on the program, we do calculate energy savings based on new measures to be installed compared with the prior electric usage. I'm not sure I'm totally following the question. For some programs, savings are deemed if we're installing lighting, for example. We do, well, I take that back. We calculate the savings based on the number of hours of operation and the wattage and things of the prior lighting.
In Austin, I'm pretty sure that the energy savings they're calculating are just for the efficiency measures that are directly installed in the buildings. If I'm correct in understanding the question, I think it's asking sort of, are the upstream energy savings, is the embedded energy in water counted? And if I understand correctly, I'm not sure I do. To my knowledge, it's not calculated in the figures that I reported, but that is something that they care about.
And DWP has just started working with a team at UC Davis under Professor Frank Lodge to look at the embedded energy in our water treatment and distribution system and our wastewater system here in the city. And as we get closer to learning more about where those energy inputs actually occur throughout the system, we'll be looking at ways to make those more efficient. But currently, as Amelia said, we do not calculate or count any savings from that.
Thank you both. We'll move on to the next question from Sid. You talked about capturing waste energy from waste and from drain pipes. There's also a lot of energy lost through chimneys and flues. Is there any way to address this wasted energy through any of your programs? Are technologies that capture waste heat and flues in chimneys part of the efficiency program?
Well, I have to admit that's not something I know a lot about, and I haven't seen much about. So there may be opportunities to capture some of those heat losses, but I'm sorry I don't know enough about that.
And certainly in some of the, forgive me, in the energy upgrade California programs, home upgrade programs, where contractors are looking at the building envelope, heat losses are modeled and identified. I'm not familiar with any specific strategies to reduce heat loss from chimneys and flues, but that is something that should be identified in an extensive audit of a residential or commercial facility, and certainly on the more comprehensive home upgrade programs.
Thanks. Our next question is from Jonathan. How will LADWP be promoting the upcoming launch of the Residential PACE program, which will be available to all LA City owners and countywide?
Thank you. Well, we are going to be working with the county as they identify the providers who will be offering the Residential PACE program here. We have a number of local nonprofit organizations that we work with through a grant program to provide energy efficiency information and outreach to our communities across the city. We'll certainly be advertising that on our website and have links to the PACE providers. We work too with the Los Angeles Better Buildings Challenge, which is currently supporting the commercial PACE program. We help fund their efforts here and try to coordinate on outreach. DWP has an electronic newsletter that we send out to our residential customers, so we'll obviously be featuring it in that channel as well.
Thank you, Gretchen. We have a question from Peter. Beyond energy savings incentives, what other value-added motivations are used to encourage measures? And this is both to Amelia and Gretchen.
I'm sorry, could you repeat that?
Yeah.
Sure, no problem. Beyond energy savings incentives, what other value-added motivations are used to encourage measures?
Do you want to start, Amelia? Or?
Yeah, I'm not sure if I fully understand the question. The benefits, I suppose there's benefits to the utilities and the customers. Do you think that we're talking about customers here?
Yes, we're speaking about customers.
Okay. Well, typically customers have been really happy with the joint utility programs because it's much easier and they see larger savings. They get sort of this one-stop shop experience. And in the case of the rebate, they're getting right now they're getting a $150 rebate as compared to a $50 rebate when PG&E was offering that rebate alone. So really just the increased savings and increased ease of achieving those savings has been a major benefit to the customers.
I would agree. Hopefully they are realizing increased comfort in their homes and offices once they have more appropriate lighting and heating and ventilation measures installed. But certainly a single point of contact, greater incentive dollars, and certainly the utilities realize greater energy savings.
Okay, great, thank you. We have a couple more questions. So the first set of questions is, do contractors need additional specialized training to know how to properly install a drain water heat recovery system? If yes, how do they get that training? And are there leading manufacturers of such systems that provide training?
That's a good question. When I was looking into this, I looked at a YouTube video and was convinced that I'm not skilled enough to do it, but someone who's pretty handy could make it like a do-it-yourself type of project. That said, I'm sure some training in this would be extremely helpful. I know of one company in particular who installs these systems. It's called Nexus E-Water. As to whether they provide training, I'm not sure about the training programs out there, unfortunately, but they might be a good first place to check, as I'm sure they would know about who does those trainings if they don't offer that themselves.
Great, thank you. Our next question is from Amy. Is there a third-party verification process for East Bay Mud and the Gloversville-Johnstown Joint Wastewater Treatment Facility for their net positive and 90% energy reduced claims? And is there any certification or recognition process for them?
That's a great question. To my knowledge, there has not been an official third-party certifier. There was a pretty extensive paper developed and submitted to the EPA about East Bay Mud. And the EPA also provides a benchmark energy use, a benchmark for energy use at wastewater treatment plants. So most of that is self-reported, but you know, when you go onto that site, you can sort of see if your wastewater treatment plant is average for your size and specs or using more or less. I think a third-party verifier might be something that happens in the future if this becomes a more significant trend. My sense is there's really only a few utilities in the U.S. that do this. It's a bit more popular and prevalent in Europe, actually. So we'll find several more case studies over there. But if we can take some lessons from there, that would help. I will also add that the Water Environment Research Foundation has been working on a project where they're converting, I think, 25 wastewater utility plants to try to make them net energy zero or net generating. So that report should be coming out hopefully within this year, I think. And that will not only help identify sort of what are the processes and challenges with that conversion for existing plants, but also, I suppose, acts as something of a third-party verifier since they're an independent research organization.
Thank you, Amelia. And we'll go with one last question. How does LADWP replace revenues lost from reduced consumption?
Leave me with the easy question at the end. Well, I don't know that I have enough detail to give you a really solid answer on that. We are pretty, well, just about midpoint through our 2010 to 2020 time frame that we're trying to reach our efficiency goals. But if you'd like to contact me afterwards, I'd be happy to get a response for you on that.
And that concludes today's talk on harnessing energy embedded in water. I'd like to thank both Amelia and Gretchen for joining us this afternoon. If you'd like to view or share a recording of today's webinar, please visit the Blueprint for Efficiency website. And remember that all Blueprint for Efficiency webinars are also posted on iTunes U. Make sure to tune in next Tuesday, March 31st, for our webinar highlighting case studies of secondary market transactions for energy efficiency. This webinar will feature speakers from the Connecticut Green Bank, the Delaware Sustainable Energy Utility Oversight Board, Craft 3, and Self-Help Credit Union. Join us to understand lessons learned from these 3 real-world deals. This is Lynn Tran from the Yale Center for Business and the Environment saying so long from New Haven, Connecticut.